Hello everyone. My name is Wilhelm Talan, and I want to make this video to understand and define linear equation and to figure out why letters were introduced in mathematics. Okay. Now let me give you an example. Uh, to define linear equation, linear equation is where a degree of an equation is 1. Example, this is a linear equation because it has a degree of 1. Example of degrees in exponents are x raised to the 1, x raised to 2, x raised to 3, and so forth and so on. Now, the reason the reason why letters were introduced is because letters were used as a representation of a missing number. Let me write it out. Sorry for my now letter can be anything like A, B, C, and so forth and so on, like X, Y, and Z. Now, letter can be called as a variable, while number can be called as constant. Okay. Now, I'm going to write an equation like 5 to make you understand even further. Okay. Pause the video if you want to solve the equation because I'm going to erase it the entire thing. So, okay. Now, to solve number 1, we need we need to put the constant to the other side using its inverse, meaning that we're gonna replicate this. So we're gonna the technique of solving a linear equation is to bring down 2x, then add plus 0. The reason we do that is because we need 2x to be alone and alone to be solved for the missing number. And now we're gonna bring now what could be a number that could add to negative 6 so that equals 0? Well, the opposite of negative 6 is positive 6. So we're going to add both sides by 6. That means that this thing will be equal to 0. And 8 plus 6 is equals 14. Now 2x plus 0 will be itself. So it would be 2x. And you can bring down 14. Now, since the coefficient is greater than 1, we need to divide itself by itself with its coefficient, which is 2. So we're going to divide it both sides by divided it by 2. 2 divided by 2 would be 1x plus 7. You can pause the video if you want, and I'm just going to erase it. Okay. Okay, in number 2, in order to solve this, we're going to put the constant to the other side once again. The technique is very, very simple. Bring down 1 half of x, then add 0, which will be, and then which will be easy for slow learners actually, and then we're gonna put an equal sign. Now, what number when added to -8 will be equal to 0, which is the inverse of itself, +8. So +8. Now, since -8 plus 8 is 0, we're going to ignore that. 14 plus 8 is 22. Now, of course, itself, 14, when you add something to 0, it will be itself. So 1 half x equals 22. Now, in order to solve this, you need to multiply the denominator, which is the same number as the numerator, which is 2, on both sides. We get is 1x equals 44, or that would be x equals 44. Now you could possibly if you want, but I'm just gonna remove it. In number 3, it's still the same thing, but except the constant is positive. So we're going to solve it again. Because we're going to use the same technique. Bring down the term. Actually, a term meaning it combines with with a number and a variable, or a constant and a variable. You can call it that, or a coefficient. So 1/4 of x. We're gonna bring it down. Then we're gonna plus 0. Figure out what number when you add it to plus +8 will become 0, and then we're just gonna put an equal sign, which is -8. So I'm gonna put -8 on both sides. Now, since we already put 0 on it, we're gonna ignore that. And then 14 minus 8 is 6. Now, of course itself would be 1/4 of x equals 6. Now we're gonna multiply the number as same as we're gonna multiply the number as same as the denominator, which is 4. Just cancel it all out, and then that means that 1x equals 24, or x is equals 24. You pause the video if you want. I'm just gonna move on. For number 4, we're going to do the same thing. We're just going to, well, actually this is the same thing. We're gonna bring it down. This will become 0, and this would become this. So the opposite of -1 would be +1. We're going to write a +1 on that, which is 0, and then +1 is 10. And then we're gonna do the same thing. Now we're going to eliminate the denominator first, so that we could solve the numerator part. So it would be 2. That means that we're gonna write it on. So that means that 4x plus 4 equals 20. It's still the same thing. We're going to use the same technique once again. So we're just going to bring down 4x, and then plus 0, and then we could the opposite of +4 would be -4. So -4 on both sides. That means that it will be it will be equal, and 20 minus 4 is 16. It's still the same thing. I'm just gonna shortcut it because it's wasting my board. So 4x equals 16. We're gonna divide it both sides by its coefficient, which is 4. Which means that x is equals 4. You can pause the video if you want. You can. For number bar, it's still the same process. I'm gonna cut it out if you want. If you want to skip the video or what. Anyway, I'm just gonna solve it. Hmm. Just gonna do this. This is equals 16. Now for this thing, we're gonna multiply its denominator by itself, which is 2, both sides. Actually, cancel, cancel, and then x is equals 32. Oh, now I want to explain why I put this here, especially number 2. I'm going to explain it to you why is it strictly 1 and why is a is greater and b is less than. So okay, in number 2, the reason why I strictly use it, I'm going to copy this. You see, the reason why is very, very simple. The reason why is 1 is representation coefficient of a variable, which states in here. I'm going to use the black marker just in case. Here. You could see why I strictly use 1 in this problem. What is A and B? A meaning a large number, while B is a small number. I'm going to put a number line for you. Anyway. Now, I'm going to put a number line. Put an arrow. Now, here is 1. Here is 1. This is where the coefficient is equal to a variable. If you go from here, it is a small number. We're going to represent as b. This includes 0, -1, and -2. And from the right side represents the a, which is the large numbers like 2, 3, and 4. Now, also examples with here is fractions. Fractions, which is very important. Now, to be example with this is part of b is 1/2 and 3/4. And from a, it's like 4/3 and hmm, well, actually, it's not negative. Uh, Actually, it's asterisk. Actually, asterisk. Just gonna put asterisk. Just asterisk, and then this is called as asterisk, not a anything. And what else there's to rate then? Yeah, 3, 7 over 3. Yeah, that is representation of A being a large number must be greater than 1, and B is less than 1. The reason why I strictly use this is because, wait, well, in the rows, if 1x, then you divided it sub by that okay, actually that's wrong. 1x under rows will always states that x, because 1 will be an invisible number because that is the invisible number of the coefficient of x. Now what if it is greater than, like example 2x equals 14. Now, if it's greater than 40, either you need to divide it by or multiply it. Since this is a whole number, just 2. Since it's a whole number, gonna divide it both sides by itself, which is 2. That's why we get x is equals 7. Now, in fractions, it's very different. That's when multiply, I'm gonna show you. If 1/4 equals of x equals 12, we can see that in order to in order to be its coefficient to be 1, you need to multiply its denominator, which is 4. That's why we can see this divided rules, divided and multiplied. X is equals 48. Now I wanted to thank you for watching this video. If you really want to, if you want me to solve a problem, you can just ask in the comments. Like and subscribe. I hope you enjoy, and Merry Christmas.